Chapter 3-4, Parallel and Perpendicular Lines. All right, so if two lines are parallel to the same line, then they are parallel to each other. Let's take a look. So right here we have three lines. It says A is parallel to B, so we can see that right here. It's indicated that A is parallel to B. And B is parallel to C. We can see that indicated right here. B is parallel to C. Then we know that A is parallel to C. So the one on top is parallel to the one on the bottom. All right, next up, if two lines are perpendicular to the same line, then they are parallel to each other. All right, let's take a look at that. So if M is perpendicular to T, all right, this symbol right here means perpendicular. All right, that means it makes a right angle. So M is perpendicular to T. We see that right here. M and T, they make a right angle. And N is perpendicular to T. Here's line N. Here's the right angle with T. Then M is parallel to N. So the one on top is parallel to the one on the bottom. And why is that? Well, if you think for a minute, what kind of angles, other than right angles, what kind of angles do we have here for the two right angles? Think about what position they're in. All right, these angles are corresponding. This angle here is on the top left. This angle here is on the top left. Those are corresponding angles. And when you have corresponding angles congruent, that proves that the lines are parallel. Okay, corresponding angles congruent proves that the lines are parallel. So we actually already knew this. We're just saying it's also true for a right angle. All right, let's try this real quick. They're saying given in a plane, R is parallel to T and S is parallel to T. Prove that R is parallel to S. Let's take a look. All right, right here we see that R and T are perpendicular. We see that S and T are perpendicular. Therefore, R is parallel to S because they are both R is perpendicular to T and S is perpendicular to T. Okay, they are both perpendicular. They are both perpendicular to the same line, T. So they are going to be parallel to each other. I'll draw the little arrowheads indicating that they're parallel. They're both perpendicular to the same line, T. All right, a carpenter plans to install molding on the sides and top of a doorway. The carpenter cuts the ends of the top piece and one end of each of the side pieces at 45-degree angles. Will the side pieces of the molding be parallel? Let's see. All right, so this is how the carpenter cut the wood. All right, and here we have a 45-degree angle, and here we have a 45-degree angle. So when we fit these two pieces together, this 45 and 45 is going to make a right angle. All right, here's the top. And then on the other side, we're going to fit these two 45s together. We have 45 here and 45 here. When you add these two, they are also going to make a right angle. Okay, this is the side, and this is the side. Okay. And tell me, do you think these two sides are parallel, and how do we know? Well, yes, these two sides are definitely parallel because they both make right angles with the top, okay? So both sides are perpendicular to the top. They make right angles, so the sides are definitely going to be parallel. All right, so let's look at got it problem 1. Can you assemble the pieces at the right to form a picture frame with opposite sides parallel? Let's see. All right, so think about how we would orient or arrange this in order to make opposite sides parallel. So this 30-degree angle right here would have to match with this angle right here. And this part right here would have to match with this 60-degree angle here. So if we added these two, 60 and 30, that'd be 90. If we added this and this, that would be 90. Also, we can take this one and put it on the other side. So this piece here, it would fit like so. All right, you'd have to take that piece and fit it right there. And let's see. Actually, that's a mistake. The 30-degree angle would have to go here. So this is the longer part, actually. This would be the longer part right here. And then it would be like so. All right, so the 30-degree piece, the 30-degree angle would have to be there. And the same thing on the other side as well. So you'd have 30 and 60. It would make a right angle right here, and it would make opposite sides parallel if you just drew this one over here. All right, in a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. All right, if N is perpendicular to L, so here's N, here's L, it's perpendicular, makes the right angle, and L is parallel to M, L is parallel to M, then N is perpendicular to M. So if there's a right angle here, there's going to be one here as well. And why is that? Because once these are parallel, we know that corresponding angles are congruent. So if there's a right angle here, there's also going to be one right there, as long as these lines are parallel. All right, in a plane, C is perpendicular to B, B is perpendicular to D, and D is perpendicular to A. Prove that C is perpendicular to A. All right, so they gave us a diagram. Let's take a look. Here's a diagram. We want to prove that C is perpendicular to A. So let's see. We have C perpendicular to B, and we have D perpendicular to B. All right, so let's write that out. C is perpendicular to B, and also D is perpendicular to B. All right, they're both perpendicular to B, so they're going to be parallel to each other. All right, so since we know this, they're both perpendicular to B, we know that C and D are parallel. C is parallel to D. And let's see, what else do we know? Here's a right angle. So A is perpendicular to D. And here's a right angle. So B is perpendicular to D. All right, if they're both perpendicular to D, they're going to be parallel to each other. So A is parallel to B. So here's A, here's B. I'll draw that in. All right, and finally, we want to prove C perpendicular to A. Well, we already have C and D parallel. C is parallel to D. And we already have D perpendicular to A. D is perpendicular to A. Therefore, if C is parallel to D and D is perpendicular to A, we know that C is perpendicular to A. So that's what they asked us to prove. All right, for this section right here, numbers 19 through 24, you want to tell how A and D relate and justify your answer. So the best thing to do for each of these problems is to just draw what they say. All right, so let's look at number 24. So the first thing, it says A is perpendicular to B. So let's draw that. All right, I will draw line A. And I'm going to make it have a right angle to line B. All right, simple. Just make it perpendicular. Next step, B is parallel to C. So I already have B. I'm going to make a line C that's parallel to line B. So here's B. It runs left to right. So I am going to draw in a line C that also runs left to right. And since it's parallel, I am going to indicate that it's parallel with those lines right there, those little arrowheads. All right, and you can extend line A. Assume that it keeps going. Finally, C is perpendicular to D. So C makes a right angle with D. We already have line C, so I'm going to make a line D that's perpendicular to that. All right, so since C runs left to right, in order to make the right angle, line D is going to have to be up and down. So that makes a right angle with C. Now they want to know the relationship between A and D. That was the instructions. Well, let's see. If these lines are parallel and it's perpendicular here, then it has to be perpendicular here as well. Because since these are parallel, these are corresponding angles right here. Same with this right angle. But it actually doesn't matter. You can take this right angle and write it here, but it doesn't matter. We can see that D is parallel to A. Okay, and that is because they are both perpendicular to line B. They make a right angle with line B. So D is parallel to A because D is perpendicular to B. Let me write that better. D is perpendicular to B, and A is perpendicular to B. All right, since they are both perpendicular to line B, they're going to be parallel to each other. So that's it.